Hey, my name is Matthew, and this video is about linear programming. And linear programming is an application of systems of inequalities. And in fact, this fourth bullet right here tells us that linear programming accounts for more than 50%, and sometimes as much as 90% of all computing time used for management decisions in business. And I would say typically what we're trying to do is, in a way, maximize or get the biggest bang for our buck. Okay, we want to optimize. We want to make the most and best use of our resources. And we're going to see some examples of that. These are going to seem like kind of childish examples maybe, but remember that if you're just being introduced to this for the first time, we don't want to start learning with something that is too intense. So let's just start with the basics. For example, in problem or example number 6, we're being told that a student earns $10 an hour for tutoring, $7 an hour as a teacher's aide. X is representing the number of hours spent tutoring, and Y the number of hours spent as a teacher's aide. And we want to write what's called the objective function that describes total weekly earnings. And it's very typical to write this equation as a Z equals equation. So the objective function, that's a highlighter. There we go. Z equals. So what's the objective, would you guess? If I'm this student, I want to make the most money possible. But maybe there are some constraints on how many hours I'm allowed to tutor or how many classes are available for me to be a teacher's aide. So there are some restrictions or some constraints, but within those constraints, I would like to maximize the amount of money that I'm making. So my objective function describes my total weekly earnings, which is $10 per hour times the number of hours that I spend tutoring, plus $7 per hour times the number of hours that I spend as a teacher's aide. That's it. For starters, when we're working with linear programming and working on optimization, the first thing that we need is a function that we will try to optimize, and that's called our objective function. Now, as I mentioned, there are some constraints like number of classes available to TA for and number of students who need tutoring and stuff like that. And those are called constraints. And example number 7 says that the student in the above example is bound by the following constraints. To have enough time for studies, the student can work no more than 20 hours per week. So I'm going to write a system of 3 inequalities. I'm going to write these as we go through these bullets. So if they can't work more than 20 hours per week, then the number of hours that they spend working as a tutor plus the number of hours that they spend working as a teacher's aide can't be more than, can be equal to, but can't be more than 20 hours. Now, if you just read this, if you walked over to somebody, if you found somebody's notebook and it had that written in it, it doesn't tell you much. So you should or may want to put down some additional little notes over here next to it that will help connect it to the situation for you. Or perhaps we could number these 1, 2, and 3, and you could number this as number 1. Or if you wanted to, if you need the reminder, number of hours as a tutor, number of hours as a teacher's aide. All right? Take as many notes as you need to. Number 2 says that the tutoring center requires that each tutor spend at least 3 hours per week tutoring. So let me just confirm that I've got my variables correct. X is the number of hours spent tutoring. Okay, good, just making sure. So the number of hours that I spend tutoring has to be at least 3 hours. And third, the tutoring center requires that each tutor spend no more than 8 hours per week tutoring. So the number of hours that I spend tutoring also has to be less than or equal to 8. Can't be greater than 8. Could be 8 or less than. It says no more than 8 hours. Okay, because we have to focus on our studies and so on. Great. So these are your constraints represented as a system of inequalities. And there's a request later in these notes, a couple of pages down or a page and a half down, that asks us to graph this system of inequalities. So as long as we have the equations right here, I'd say let's just go ahead and graph these. Before I graph them, however, I'm going to modify this one and write it as y is less than or equal to negative x plus 20. That way it looks more like y equals mx plus b. And let's do some graphing. Put our final result down here, and I'm really only focused on the first quadrant. My x values and my y values are going to be positive because they represent an amount of time. And my x-axis is going to be my horizontal, y will be vertical. Remember that x and y in this case represent number of hours spent tutoring and number of hours spent as a TA, where x is tutoring. All right, so let's look at our first inequality. Y is less than or equal to negative x plus 20. So I need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wow, that was great. And then I'm going to have to come all the way over to 20 over here also. So there's a 20, there's a 20. The line that I'm going to draw passes through those 2 points. There we go. That is inequality number 1. So I labeled it with a little 1. And we can use our test point of 0, 0. And you will find that we do need to shade below. If you're not sure what I mean by a test point of 0, 0, then you need to go back and watch the previous video. So I'm just doing a bit of shading in here. All right, let's grab a different color and look at inequality number 2. X is greater than or equal to 3. Oops, that's a highlighter. Not anymore, it's not. 1, 2, 3. All right, so I'm just going to label this with a 3 right here. And that's a vertical line. And it says x is greater than 3. So I'm going to be shading everywhere to the right of 3. Now I'm shading, all the way over to the right. I didn't really need to do that because I know that I'm only concerned with where my shaded regions are going to overlap. So really I didn't need to shade this stuff out here. Once you do a handful of these problems, you'll start to make your process a little bit more efficient. So ultimately I could come out and erase this stuff. And also our x values need to be less than or equal to 8. 4, 5, 6, 7, 8. So don't be too hard on yourself with these graphs. Just make sure that you're labeling things as you go. An x value of 3, an x value of 8. Let's do some more shading. Maybe grab a different color for that one. We could use red, I suppose. Oh, that's a little excessive. There we go. So we'll do that one in red, and we can do our shading. Let's go to the left with this one. And again, don't really need to be shading that far over. Okay, the region that we're concerned with is where these things overlap, where these shaded regions overlap. And where is that? It's in here. So the next phase in this process of linear programming and optimization is going to involve an inspection just of that sort of high-rise downtown New York City office building looking kind of a purple region there. Okay, it's a trapezoid, actually. Okay, we're going to come back to that because I want to show you that these steps are printed for you here. So solving a linear programming problem. We have our z equals equation, so that's our objective function. We have graphed our constraints on the xy axis. And if a maximum or minimum value of z exists, it can be determined as follows. Graph the system of inequalities representing the constraints. We just did that. And then find the value of the objective function at each corner or vertex of the graphed region. And that's what we're going to do next. We're going to come into here. I don't know what color to use anymore. We need more colors, all the colors. Let's use this one. We're going to come in and we're going to look at this vertex, this one, and this one. Those vertices, those points of intersection between those lines have coordinates x, y. We're going to take those x, y values and plug them into our objective function and see which ordered pair maximizes our students' income for the week. Which ordered pair, which number of hours spent tutoring and TAing is going to maximize the student's income for the week. Let's write down our objective function again. I need to, oh, there it is. No, that's not it. 10x plus 7y, I think it was. Yep, there it is. All right, so that was our objective function. What are the coordinates at the vertices in this beautiful graph that we drew? That looks like 3, 17. This would be 8, 12. How do I know that, by the way? Those two numbers add to 20. These two numbers add to 20. Where did I get the 3 from? How about here? Where did I get the 8 from? How about there? I've done a lot of these kinds of problems, so I know what to look for, but I want to highlight for you that if these equations were more complicated, you would have to be solving a system of equations in order to find that point of intersection, which turns out to be 317. And then you would have to solve a different system of equations in order to find that point of intersection, which would be equation number 1 and equation number 3. So that's why we start out with these basics, because almost visually, or if you had a piece of graph paper, it would be easy enough for you to find these points of intersection. Okay, and then 3, 0 and 8, 0. If you want to write those down there, you can. 3, 0 and 8, 0. All right, let's start plugging them in. Z equals, I'm going to pause this. You don't need to see and hear me do arithmetic. If you want to do the arithmetic on your own, that's fine. Otherwise, I'm going to pause this. And then next time, well, I'm going to snap my fingers, and then all of a sudden, there's going to be a whole bunch of solutions. Amazing. So silly. Okay, so what I did is I took my ordered pairs, and you can see them here. Here's the 3, 17, 8, 12, 3, 0, 8, 0. I just took them, each ordered pair, plugged them in one at a time, and calculated the corresponding objective function output values. And you can see that the largest one of those is 164. So the ordered pair 8, 12 maximizes our objective function. So how many hours does the student want to work in order to maximize their weekly income? They want to spend 8 hours working as a tutor and 12 hours per week working as a TA. And they're maximizing it turns out, as a result, they're maximizing the total number of hours that they're able to work per week. That sounds nice. I've been spending about 20 hours a week making videos. Want to know how much extra I get paid? Honestly, it's been a really good experience. And if I ever go through and make a separate video series that's even more my own, I will definitely be able to do better next time. I've got a couple of little kinks that I want to work out. Got to get the video and the audio synced up a little bit better. Had some little glitches right here at the end, but overall it's been a pretty cool experience. This was a separate question that was sort of in the midst of everything that we were just doing. Well, actually, let me come back to that in a second. Graph the system of inequalities from example number 7. We already did that. Used only the first quadrant, right? Because our x and y values were time values, so they weren't going to be negative. And if you actually wanted to come in here, what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 doesn't take you all the way to 20, unfortunately. So maybe you want to do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. If you have these printable notes, or if you have some graph paper, whichever suits you, you might want to redraw just the area that we shaded and checked the vertices for, if you would like to have that at this stage in your notes. Use only the first quadrant. Great, so we needed to graph it, so we did that there. And then evaluate the function for total weekly earnings at each of the 4 vertices. Oh, and they gave us the vertices, isn't that nice? And so the very tail end of that question is to complete the missing portions of this statement. So the student can earn the maximum amount per week by tutoring for, I think our tutoring number of hours was 8, and the TA number of hours was 12. Is that right? Well, you can adjust those accordingly as necessary, and I think the maximum amount was 169, maybe. I work with a lot of numbers. The short-term memory on holding those kinds of numbers in the front of my mind is 8 and 12. Yeah, it was. And 164, not 169. So that's a pretty good extra weekly slice of income. And I think that answers all of the questions that we had. Yeah, nice. All right, so that's the end of those notes. The only other thing that I was going to point out to you is that it could be that you're given an equation where the graphing of the constraints has already been done for you. The vertices have already been identified, as is the case in this example problem. And you're right at the top of the screen being given your objective function. And all you have to do is take these ordered pairs, plug them into the objective function, and figure out which one either maximizes or minimizes your objective function. In this case, you're being asked to figure out which one maximizes. And for those of you who are my students, I would like to say thank you so much. It has been a heck of a semester. I've recorded these videos during the fall of 2020, which means it's been a super weird COVID experience this semester. And this is the last section of our notes for the semester. Anyone else who's not one of my students who joined me for any of these videos, thank you so much for joining me, and I look forward to seeing you. Thanks so much.